Hello and welcome back. Let's have a look at simple linear regression. So here's the equation, and we will look at the parts of this equation one by one. So on the left, we have our dependent variable, which we're trying to predict. On the right, we have our independent variable, which is the predictor. Here we have B0, which is the y-intercept, also known as the constant, and B1 is the slope coefficient. Now, to make things more fun, we're going to use that example we mentioned about predicting the output of potatoes on a farm based on the amount of fertilizer that we use. So here's our equation, and if we modify it to fit our example, it will look like this. And let's say that we ran the simple linear regression algorithm and it came up with the following values. B0 equals 8 tons and B1 equals 3 tons per kilogram. So what does this mean in terms of the graphical representation? How can we better understand this on an intuitive level? So let's plot a simple scatter plot. So here we have on the x-axis a nitrogen fertilizer used in kilograms. That's our x1 variable. And here we have the y variable, which is the potato yield in tons. And here on the scatter plot, we have several data points. What are these data points? Well, each one represents a separate harvest on the farm that we're talking about. So multiple times the potatoes were harvested over many years, and the farmer recorded how much fertilizer they used and also how many potatoes they were able to harvest in that specific season. So there is our scatter plot, and what this equation on the left represents is a sloped line that goes through our points. The y-intercept is over here. That's our 8 tons. And what the slope coefficient means is that if you increase the amount of nitrogen fertilizer by 1 kilogram, then the amount of potato output will increase by 3 tons. And of course, these numbers are made up for illustrative purposes. So there we go. That's how the simple linear regression works. And I look forward to seeing you next time. Until then, enjoy machine learning.